It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
A very good evening to all my dear friends. Welcome to Unacademy. कैसे हो मेरे प्यारे दोस्तों? Yes, welcome dear ऋषिकेश. Yes, done with the dinner. करते हैं स्टार्ट अपना मैराथन सेशन ऑन प्री स्ट्रेस कॉन्क्रीट. और ये सेशन इसलिए क्योंकि आरसीसी के 2 मैराथन हुए थे and in those session I couldn't complete pre stress concrete, and as I promised you I will be coming with this separate session which will be containing only pre stress concrete. So consider it also the part of end game marathon session and you can use this session for your revision. Okay, so मैं हूँ आप लोगों का दोस्त ऐश्वर्य. गेट टीएससी के लिए आपको पढ़ाता हूँ. I have done my masters from IIT Delhi and BTech from Jamia Millia Islamia. 4 times I have qualified GATE with my best AIER 226. I do have 7 years of teaching experience and 2 years of industrial experience, and I used to cover around 50% of the subjects in civil engineering. And this is our official Telegram channel. आप इसको join कर सकते हो. इसमें हम आपको देते हैं YouTube के notifications, YouTube e-notes and all. And here we do have many free content available on Unacademy official YouTube channel as well as on Unacademy special classes. But still, we recommend our learners to go for our Plus and Iconic plan. The reason being, Plus में हम आपको देते हैं daily live classes, weekly test, structured course, crash courses, rank improvement batches, and unlimited access to the content. And if I'm talking about the iconic one, which is the superset of Plus, where we are going to give you all the benefit of Plus. Apart from that, also you are going to get the personal coach who is going to plan your study, who is going to give the study booster session for you, who is going to analyze your test at the personalized level. Not only this, also you are going to get the specialized notes and practice sets along with the dedicated doubt clearing educator. So whether it is a matter of Plus or iconic, feel free to use the code AISH10. Unacademy subscription plus subscription model is available from 3 months to 2 years, or Iconic is also available from 6 months to 2 years. For instant 10% off, you guys can use the code AISH10. But if you are applying this code now, है ना, 1.5 घंटा अभी भी बचा हुआ है, अगर आप ये कोड अभी लगाते हो डियर, तो आपको मिलता है 20% ऑफ। ठीक है, तो सब्सक्रिप्शन प्लान कर रहे हो तो पहले कोड लगा करके 20% ऑफ ले लीजिए, उसके बाद आप इस लेक्चर में आ जाइए। ओके, सो इट्स नॉट टू लेट, स्टिल 1.5 hours left. New batches you can see we have started in Plus and Iconic platform, and in Evolve and Ascent batches we have started with the strength of material, and now it's time to revise, to brush up the concepts on pre-stressed concrete, and it is the session number 1, or you can consider it session 3 if you are watching it in sequence. So already 2 sessions I have taken, one on 26th and another on 27, okay, on RCC. So you can consider it session 3 of marathon endgame session, है ना। मुझे लगता है ये तो अब हाँ बिना देखकर भी बोल सकता हूँ, यस आई थिंक सो, हाँ ये तो है। तो स्टार्ट करें डियर, स्टार्ट करें। तो कंटेंट के नाम पे हमारे पास ये 3 चीजें कवर होने वाली है। इंट्रोडक्शन टू प्री स्ट्रेस कॉन्क्रीट, व्हाट ऑल आर द एडवांटेजेस ऑफ प्री स्ट्रेस कॉन्क्रीट, डिसएडवांटेजेस, okay, what are the various ways of pre-stressing, and what all are the requirement of minimum grade of steel and concrete. And in second phase I will be covering the analysis portion, and under analysis portion we will be covering 3 methods: stress method, load balancing method, and P-line C-line method. और final phase में हम लोग देखेंगे losses, that what all are the losses which are occurring in the pre-stress concrete. Okay, so let's start dear. What is pre-stress concrete? So everybody ready? So इन 3 फेज में से 2 फेज की पीपीटी आई विल बी यूजिंग, और लॉसेस जो एक छोटा पोर्शन है उसको मैं लिख करके आपको समझा दूंगा, बट यस दीज 2 पीपीटीज आई विल बी यूजिंग डियर। सो फर्स्ट वन इज प्री स्ट्रेस्ड कॉन्क्रीट। क्या होता है प्री स्ट्रेस्ड कॉन्क्रीट? नाम से क्लियर है कि एक ऐसा कॉन्क्रीट जो पहले से स्ट्रेस्ड है। क्यों है वो पहले से स्ट्रेस्ड? Basically, it is a concrete in which internal stress of suitable magnitude and distribution are introduced so that the stresses resulting from the external load are counteracted to a desired degree. देखो डियर, अपने कन्वेंशनल आरसीसी में क्या होता था, बिलो ऑफ द न्यूट्रल एक्सिस और इन द टेंशन जोन वी वर कंप्लीटली नेग्लेक्टिंग द कंक्रीट, ऑल्दो वी आर पेइंग फॉर दैट कंक्रीट, है ना। कॉन्ट्रैक्टर तो हमसे उस कंक्रीट का भी पैसा ले रहा है, बट उसको हम लोग डिजाइन पॉइंट ऑफ व्यू से या एनालिसिस पॉइंट ऑफ व्यू से कंसिडर नहीं करते थे, एज पर द assumption of LSM and WSM that concrete in the tensile zone is to be ignored. बट अगर मैं पहले से ही उस टेंशन वाले कंक्रीट को कंप्रेशन देके रखूं, और आज जब मेरे डेड लोड या लाइव लोड के कारण टेंशन डेवलप हो रहा है, सो मेरा वो टेंशन पहले वो कंप्रेशन को कंपनसेट करेगा, देन ओनली इट विल बी अलाउड टू गिव यू सम नेट टेंशन. सो इन ऑर्डर टू रेसिस्ट सच टेंशन, okay, or you can say in order to effectively use your normal concrete, the concept of pre-stressed concrete is introduced. Okay, so that's why it is written there. Already we are doing a pre-stressing of in such a manner that even if the external loads come, the initial stresses are going to counteract up to a desired degree. So this is a concept here. Now, why pre-stressed concrete when we have already our RCC structure? I told you, in RCC structure, in WSM as well as in LSM, the concrete in the tension zone is completely neglected. यही बताया था भी मैंने. Okay, whole concrete was not participating in taking the external force. Only that concrete was effective, which was coming in the compression zone. जो आपके compression zone में आ रही थी concrete, वही बस effective थी. टेंशन वाली जो कंक्रीट थी उसको आप नजरअंदाज करते थे, ऑल्दो इसके लिए भी आप पैसा देते थे, बट स्ट्रेंथ पॉइंट ऑफ व्यू से इट इज नॉट गोइंग टू पार्टिसिपेट. सो नाउ व्हाट विल वी डू, व्हाट वी विल बी डूइंग, वी विल ऑलरेडी अप्लाई सम एक्सटर्नल प्री स्ट्रेसिंग बिफोर द एप्लीकेशन ऑफ लोड. उसके भी करने के अलग अलग तरीके होंगे, वी विल बी वॉचिंग दैट. एंड ड्यू टू दैट इनिशियल प्री स्ट्रेसिंग, व्हेन दिस एक्सटर्नल लोड केम, So some part of this external load will counteract the initial pre-stresses, then it will going to give you net tension or compression, or net even can be equal to 0. So that is the purpose of providing pre-stress concrete. I hope the concept is clear to you guys. Okay, so we can say that in pre-stress concrete, in order to utilize this section more effectively, okay, we are introducing the compressive stresses initially, okay, before the loading, where the external loads would normally cause the tensile stress. So we are going to compress that portion of concrete which would be in a tension due to the external load. So by doing this, we are using our RCC in a more effective manner. So tell me if the basic funda of pre-stressed is clear to you or not. ऐसे समझ लीजिए कि ये मेरे पास नॉर्मल स्टील सेक्शन, कंक्रीट सेक्शन है. ओके, already it is compressed. So the revised position of this would be maybe like this. Okay, if I am going to compress it from the center, now when the external load came, so due to the application of external load, now the deflected pattern may be like this. So still it is going to reach at this level. So we can say that no net stresses are developed even now. So this is the beauty of pre-stressed concrete. क्लियर है कि नहीं? बट हाँ, यहाँ पे कुछ दिक्कतें भी हैं. ये सब करने के लिए आपको apparatus चाहिए होते हैं, आपको प्रॉपर बैचिंग प्लांट चाहिए होता है, आपको एक स्किल्ड लेबर चाहिए होती है, जिसके कारण आपकी कॉस्टिंग थोड़ी सी बढ़ जाती है, बट तब भी वो कॉस्टिंग कंपनसेट कर लेती है अपना अमाउंट जब आप इससे साइट पे डिजाइन के नाम पे कॉस्ट को रिड्यूस करते हो. ओके, होता क्या है यहाँ पे कि इफ द एंटायर कंक्रीट इज गोइंग टू टेक पार्टिसिपेशन इन टेकिंग द एक्सटर्नल लोड, देन वी वुड बी नीडिंग लेस एरिया ऑफ कंक्रीट इन कंपैरिजन टू आवर कन्वेंशनल WSM और LSM सेक्शन. आर यू गेटिंग द पॉइंट और नॉट? सो दिस इज यस. कपड़े सुखाने की रस्सी इज ऑल्सो द एग्जाम्पल. अगर आपने कपड़े सुखाने की रस्सी पहले से ही बहुत ज्यादा स्ट्रेच्ड कर रखी है, सो अब जब आप उसके ऊपर कपड़े डालोगे, देन स्टिल इट इज नॉट नेसेसरी कि ड्यू टू द वेट ऑफ दैट क्लॉथ्स नाउ इट इज गोइंग टू रीच द टेंसाइल स्ट्रेसेस, इन फैक्ट इन द बॉटम फाइबर्स. ओके, नाउ ये सब करने के लिए डियर, ये तो है नहीं कि आप प्री स्ट्रेसिंग कंक्रीट करोगे तो किसी भी ग्रेड से, किसी भी ग्रेड ऑफ कंक्रीट या स्टील से कर दोगे. तो ये सब करने के लिए आपको हाई स्ट्रेंथ स्टील एज वेल एज हाई स्ट्रेंथ कंक्रीट चाहिए होता है. ओके, जैसे मैं कहूं कि देयर इज अ नेसेसिटी ऑफ हाई स्ट्रेंथ स्टील, देन ओनली द प्री स्ट्रेसिंग कैन बी डन, और देयर इज अ नेसेसिटी ऑफ हाई स्ट्रेंथ कंक्रीट, देन ओनली द प्री स्ट्रेसिंग कैन बी डन. व्हाट इज द रीजन बिहाइंड दिस? Normally steel which we are using in our conventional LSM and WSM is Fe250 और Fe415, या चलो हद से हद Fe500 ले लोगे. यही 3 ग्रेड आप कॉमनली यूज करते हो. ओके, सो यहाँ पे जो लॉसेज होते हैं वो भी बहुत ज्यादा ऑर्डर में होते हैं. स्ट्रेन लॉस देखा जाए तो 0.0008, यंग्स मॉडुलस से इसको मल्टीप्लाई करोगे तो जो स्ट्रेस लॉस आपका हो रहा है वही 160 का हो रहा है. और ये तो मैंने बस आपको स्ट्रेन लॉस लेके दिखाया है. अगर मैं सारे के सारे लॉसेस, पॉसिबल लॉसेस को यहाँ पे अकाउंट करूं, मे बी ड्यू टू क्रीप, श्रिंकेज, इलास्टिक शॉर्टनिंग, डिफॉर्मेशन, फ्रिक्शन, ओके, कर्वेचर, देन दीज टोटल लॉसेस कम्स इन द रेंज ऑफ 200 to 300 न्यूटन पर mm स्क्वायर. क्लियर है कि नहीं है? बात समझ में आ रही कि नहीं आ रही? और आप 200 से 300 का लॉस हो रहा है और आप यूज कर रहे हो 415 या 500 या 250, तो क्या बचा? सो मोस्ट ऑफ द स्ट्रेंथ विल बी कंज्यूम्ड इन लॉसेस ओनली. सो नेट फोर्स विच इज अवेलेबल फॉर प्री स्ट्रेसिंग would be very very less. So that is the reason why we will be needing high strength steel, maybe of the order of 1000 MPa or 1200 MPa or 1500 MPa. तो उस रेंज में बात करते हैं हम लोग, ठीक है, क्योंकि यहाँ पे लॉसेज ही 200 से 300 हो रहे हैं. 415 का FY 230 आता है. Are you getting the point or not? So that's the reason why do we need high strength steel. चलो स्टील का तो समझ में आ गया दोस्तों. अब कंक्रीट क्यों चाहिए? कंक्रीट क्यों चाहिए? सर आरसीसी इज ओके फॉर मी बट प्री स्ट्रेसिंग इज फीलिंग टफ. तो एक रिवीजन सेशन ये लगा के देखो, बताना मुझे कैसा लगा आपको कि नहीं, वरना फुल लेंथ कोर्स भी है प्री स्ट्रेस कंक्रीट का. आई हैव टेकन ट्वाइस, वन अंडर आरसीसी and earlier as well I have taken a full course on pre-stress concrete and this course is also available in special class. in fact 3 बार मैंने pre-stress cover किया है, 2 बार YouTube पे, 1 बार ऐप पे. in fact ये 4th time होने वाला है, ये 4th time होने वाला है. okay, so there is a necessity of high strength steel. अब concrete क्यों चाहिए high grade का? कंक्रीट नॉर्मली आप जो अपने कन्वेंशनल आरसीसी में यूज करते हो वो करते हो M15, M20, M25, बट यहाँ पे M30, M40 से नीचे आप जाते ही नहीं हो. सो व्हाई डू वी नीड हाई स्ट्रेंथ कंक्रीट हियर? वी नो एज वी आर गोइंग टू इंक्रीज द ग्रेड ऑफ कंक्रीट देन लॉट मेनी प्रॉपर्टीज improves. Its bearing strength improves, compressive strength improves, shear strength improves. Okay, so all those Young's modulus improves, all those properties are going to improve. So in order to bear the high bearing stresses at the ends, we need high strength concrete. To bear the high bond stress between steel and concrete, we need high strength concrete, because as we are increasing the grade of concrete, the bond strength also increases, the bearing stress is also increasing, and as the grading of concrete becomes higher, the losses due to shrinkage creep also reduces, because Young's modulus increases and the material which is having high value of Young's modulus, they are less prone to creep and shrinkage losses. Okay, so to reduce losses due to creep and shrinkage, to bear high bond stress, to bear high bearing stresses, we will be needing high strength concrete. Actually high bearing stresses we will be needing in post tensioning pre-stress concrete. High bond stress we will be needing in pre-tensioning. Actually pre-tensioning करने के भी 2 तरीके होते हैं. pre-stress में कंक्रीट को स्ट्रेस देने के भी 2 तरीके होते हैं. एक तरीका होता है मेरे पास पोस्ट टेंशनिंग, एक होता है प्री टेंशनिंग. अब ये पोस्ट टेंशनिंग प्री टेंशनिंग क्या होते हैं, नाम से क्लियर है, इसके ऊपर बात करते हैं. अभी पोस्ट टेंशनिंग में हम कंक्रीट कास्ट करने के बाद उसको स्ट्रेस देंगे, और प्री टेंशनिंग में हम कंक्रीट कास्ट करने से पहले ही ऐसा अरेंजमेंट करके रखेंगे कि मेरा जो कंक्रीट है उसमें स्ट्रेस आ जाए. आर यू गेटिंग द पॉइंट और नॉट? ओके, सो लेट मी एक्सप्लेन यू द टाइप ऑफ प्री स्ट्रेसिंग. एज आई टोल्ड यू देयर आर 2 टाइप ऑफ प्री स्ट्रेसिंग. पहला है प्री टेंशनिंग प्री स्ट्रेसिंग, और दूसरा है पोस्ट टेंशनिंग प्री स्ट्रेसिंग. नाउ व्हाट इज द डिफरेंस बिटवीन प्री एंड पोस्ट? एज आई टोल्ड यू, प्री में आप पहले से ही कंक्रीट को टेंशन देने का प्रबंध करके रखोगे, और पोस्ट में आप कंक्रीट कास्ट करने के बाद उसको खींचोगे. ओके, लेट मी एक्सप्लेन यू इन मोर डिटेल मैनर व्हाट इज हैपनिंग इन प्री टेंशनिंग. पहले आपने 2 एंड से वायर कनेक्ट करी, अब इस वायर को आपके दम के खींच दिया. देयर इज ह्यूज स्ट्रेन stored in these steel wires, also known as steel tendons. So now after stretching your wire, ये वायर कैसे स्ट्रेच करोगे? आप इसको एंकर कर दोगे, या हाइड्रोलिक जैक लगा करके वायर खींचोगे, वायर को पुल दोगे, पुल करने के बाद इसको आप एंकर कर दोगे. अब ये वायर आपकी एकदम स्ट्रेच्ड है. अब जब इसके ऊपर आप कंक्रीट कास्ट करोगे डियर, इसके ऊपर जब आप कंक्रीट कास्ट करोगे, और कंक्रीट कास्ट मल्टीपल कर सकते हो, जितना बड़ा आपका प्लांट है उतनी लंबी वायर्स. एंड ये तो मैं आपको सिर्फ एक व्यू दिखा रहा हूं. देयर विल बी वायर्स बिहाइंड वायर्स बिहाइंड वायर्स. सो n number of sections you can plot in on a single batch. So after casting the concrete, what you need to do, you need to cut this wire. If you are going to cut this wire, then what would happen? Steel will try to contract itself, and due to the good bond action between steel and concrete, the surrounding concrete also gets contracted and compressive stress is stored in your concrete. तो यहाँ पे पूरा का पूरा गेम दोस्तों जो हो रहा है ना, वो हो रहा है due to the bond action between steel and concrete. So that is the reason why in pre-tensioning procedure we will be needing such a concrete whose bond strength is very good. And as per the codal provision, that minimum grade of concrete which you will be needing in pre-tensioning pre-stressed concrete is M40. M40 is the minimum recommendation. You cannot use any grade lesser than this in pre-tensioning process. Okay, so you cannot use any grade less than M40 in pre-tensioning process. Okay, the beauty of this method is you will be able to produce n number of similar products. Like your railway slippers. Railway slippers are also pre-tension members. Poles are also pre-tension members. They are casted by this mechanism. This method is also known as Hoyer's method. This method is also known as Hoyer's method of casting pre-stressed member. Okay, so these are some salient points of pre-tensioning pre-stressed concrete. Here the steel tendons are placed in predetermined position. One end is secure and another end is pulled and fixed it to another. Then after the concrete is casted. So you can also define it pre-tensioning because you have stretched your steel wire before the casting of concrete. That's why tensioning procedure have been taken place earlier than that of the casting of concrete. So that's why it is pre-tensioning, मतलब पहले से ही tensioning करके रखी हुई है. So after pre-tensioning, your concrete is casted, then wires are cut, then they are contracted due to the good bond action. Okay, is it clear? So after this, the reinforcements are cut and then they are trying to resume their original length, and due to the bond action between steel and concrete, the surrounding concrete will be compressed by the bond action. So that is the concept here. Okay. Now the procedure in post-tensioning pre-stressed concrete is different. From name itself it is clear that here first of all you are going to cast your concrete, but whenever you are going to cast your concrete you will be placing some space in between. How you can place a space in between? आपने घर बनते हुए देखा होगा, आप क्या करते हो, होल करके जब लेंटर डलता है, जब छत डलती है तो आप पहले से ही इलेक्ट्रिसिटी वायर्स के लिए पाइपिंग वगैरह डाल देते हो. जब आप कंक्रीट कास्ट करोगे तो आप पहले से ही अपनी डिजायर्ड लोकेशन पे पाइप वगैरह फिट कर दोगे एंड दीज आर नोन एज डक्ट. अब जब आपने कंक्रीट को पोर किया तो उस जगह को छोड़ के बाकी हर जगह कंक्रीट है. तो जब आपकी कंक्रीट सूख जाएगी तो मैच्योर हो जाएगी तो आपको एक रेडीमेड डक्ट मिलेगा. अब इस डक्ट में से यू विल बी पासिंग द मल्टीपल वायर्स एंड आफ्टर these wires, after the interference of these wires, you are going to pull this wire. By the mean you are going to pull this wire, that pulling of wire is action, and as a reaction you are going to compress your concrete. So wire will be pulled and concrete will be compressed. So here after the casting of concrete, wires are pulled and you are pushing your concrete. So concrete is getting stressed by the compression mean. So this procedure is known as post-tensioning procedure. You can see that the duct is placed inside the formwork when tender has to be placed. Concrete is poured in the formwork and allowed to harden after curing. After that, tendons are placed in the duct and anchored on one side, and here the tendons are stressed by pulling with the help of hydraulic jacks or jacks, and void between the tendon and duct is filled with grout under pressure. Okay, now the tendons are cut. देखो void भी तो रह जाएंगे ना, अगर आप यहाँ वायर खींचूंगा तो जो यहाँ पे गैप है इसको आप ग्राउटिंग से करोगे. क्लियर है? So now the tendons are cut and the tension force is released. Okay. Sir, kindly give any example of post-tensioning pre-stressed concrete where we use this. Ram Singh Rathod. Dear, we use it very much in metro bridges. Have you seen the metro girders? Nowadays projects of metro are quite common, okay, especially in metropolitan cities. So you can see they are casting the member, they are providing the column first. After that they brought some ready-made section. You might have seen their cross section is like this, and you might have observed that those cross sections are having already some holes known as duct. So when you are casting this section or placing this section with the help of jacks, big jacks, you can say cranes. So after that you are going to insert wires here and you are going to tie it. Okay, so these are the method, these are the example of post tensioning pre-stressed concrete. Okay, so metro girders, are you getting the point or not? Okay, you know why do you need high grade here? Because whenever you are going to pull this wire and whenever you are going to bind this, so directly your concrete has to bear this anchorage. So it is going to produce the huge bearing stress on your concrete which is near to the connection. But concrete is already good in compression, so good in bearing. So here instead of M40 you can even plan for M30, because M30 is the minimum requirement here, because M30 also provides you the desired bearing strength. But in pre-tensioning, what is happening, the entire game has been set up based on bond action. So we need good bond, and bond stress is generally increases, but it is not high as bearing strength. So that's why we are using minimum M40 here, and code has set M30 as the criteria in post tensioning. Is it clear to all? Ram Singh, did you get your example? Tell me. Okay, so here the tendons are stressed by pulling with the help of jacks. Voids between the tendon and duct is filled with grout under pressure. After that the tendons are now cut and they are released. Okay, this is a procedure of post tensioning. So the key point is, in post tensioning, concrete wires are placed after the casting of concrete, and then we are applying tensioning process. Here pre and post are relative with respect to the casting of concrete. If tensioning is done before the casting of concrete, it is pre. If tensioning is done here after the casting of concrete, it is post. So pre and post are representing the time period, and the reference for them is the casting of concrete. Is it clear? Is it clear to everybody? Okay. Now, as I told you already, that in pre-tensioning M40 we are going to use. In post-tensioning minimum M30 we are going to use. If somebody asks you what is the minimum grade of concrete which we used in pre-stress technology, you can say M30. But if somebody asks you what is the minimum grade of concrete in pre-tensioning pre-stressed concrete, then you have to make sure that the answer is M40. So read the question very carefully. So 2 times in past the same model have been asked. Is it clear? Okay. Now, what all are the advantages of pre-stressed concrete? What all are the advantages of pre-stressed concrete? The very first advantage is it is going to utilize your cross section more effectively. In fact, entire cross section, most of the time entire cross section is utilized, whereas in case of your LSM and WSM, you have observed that area under the neutral area in the tension zone, concrete area in the tension zone is to be neglected from tension point of view, from strength point of view. So that concrete is utilized here. So if entire concrete is utilized, then in order to resist the same load, less area of cross section would be required. If less area of the cross section would be required, it will reduce the weight of the structure. It will reduce the dead weight of the structure. If dead weight of the structure is less, then the cost of supporting structure like your columns, then footing, okay, they will also be reduced. They will also be reduced. Okay. And generally deflection is the challenge. We have seen in marathon session 2 that in slab and beam we do a deflection check. So normally we do not provide a very long span of a structure in RCC, especially in case of cantilever simply supported. Okay, but if it is having good shearing strength, if it is having good bearing, then the section can be prolonged. That is also the reason why we are using the post-tensioning pre-stressed concrete member in a metro girder, because you can actually set up your span longer. आप देखोगे कि the spacing between two pillars, two columns are wide as compared to your normal RCC bridge, because here you can go with the longer span. Here you can go with longer span. Okay. Is there any other category to select minimum grade like mild, moderate, severe here as well? Ankit, yes, those things are mentioned, but for that we have to read a separate code 1393. Okay, that much is not the part of our syllabus. In fact, I have also never been through that code. Okay, but there should be, but we have to see the minimum grade as per the bond action as well as the bearing action. So from that, logically we can define why the value of concrete is higher in pre-tension pre-stress concrete rather than in post-tension, because in post-tension bearing is the criteria, in pre-tension bond is the criteria. Okay, chaliye. So it is also useful for long span of structure, and also you can get the improved shearing resistance. It is also quite common. Like suppose there are two objects. Suppose there are two objects like this. Okay, suppose there are two objects. You can see the relative displacement between two objects. Okay, if they are normally held together. But suppose if both of these members are compressed now. Okay, I have applied a compressive stress here. Then do you really think now the relative movement is easier? So as you are increasing the compressive strength, then automatically your shear, the tangential displacement between or the relative displacement between two sections, it will also be improved. So as you are increasing the grade of concrete, the shearing resistance increases. And in case of pre-stressed concrete, whenever there is the confinement, so the shearing strength would be more enhanced. Okay, so that is the reason why we can say that pre-stressed concrete section are more good. Pre-stressed concrete section are more good in taking shearing. Okay, you can also justify it from the Mohr circle that in first case it is like this. Okay, now in second case it is like this. So here you can see that shear strength of the concrete member is more whenever it is already compressed. Okay, so that is the case. So this is the advantage of pre-stressed concrete over RCC. Although I am not telling you the disadvantage, but disadvantages are also there. Machines, tools are expensive. Labor we need is skilled. Okay, so all these are also the disadvantage of pre-stressed concrete. Okay, are you getting the point or not? Okay, now we have to start analysis. So this is the basic introduction. In basic introduction we have covered that what all are the advantages, what is pre-tensioning, what is post-tensioning, and why do we need high strength grade of steel and concrete. Okay, so these things we have covered in the basics introduction portion. Now the analysis. So before starting analysis we must be familiar with, sir, if we have to choose from pre or post, which one have more strength? Dear Ankit, not pre or post we can say, both are relevant, that's why both the techniques are used very much. Okay, but it is as per the project. Like you can play more in post tensioning pre-stressed concrete. When I said you can play more, means you will be able to counteract the stresses as the way you want in case of your post tension pre-stress concrete. That is why that is used. But whenever you need sections in bulk quantity, like I told you example of railway sleepers. Okay, whenever you need a pre-stressed member in bulk quantity, then you go for pre-tension technique, because already the tension is there, already you are casting the concrete and you can get n number of similar members at an instant. But the thing is, in pre-tension pre-stress concrete, most of the time the wire is straight. But what we can do in post-tension pre-stressed concrete, we can give the wire in the required shape. I will also tell you that there is also the effect of shape. The difference is there if you are going to provide the wires in the horizontal manner, or in the triangular manner, or in the parabolic manner. So they all are going to be more and more significant. So such things you can easily do in post-tension pre-stress concrete. That's why it is also relevant. In spite, and second plus point with post-tension pre-stress concrete is it can work even with less grade of concrete. And the second thing, why it is difficult to answer your question that which one is better, because we cannot compare to them up to same extent. Suppose if somebody is working on post-tension pre-stress concrete, and in post-tension he is taking or she is taking M40, and in pre-tension also he is taking M40. In that case, post-tension would be more effective. But if somebody is taking post-tension to 40 and or 50, and pre-tension to 40, or pre-tension also to 50, then in that case your pre-tension can also be effective. So it depends upon load many parameters. Okay, so it cannot be defined solely on the basis of grade of concrete and all. Okay, it is also a function of wire, that how strong are your wires. Suppose I have a concrete which is able to compress, which wants to compress, but the wires are not that much capable to produce that much of compressive stress or strain. So in that case the combination is ineffective. Okay, so not only on the basis of concrete, but as a system we have to judge which is going to give you more strength. And anyone can give more strength, let me tell you. But the plus point in post-tension pre-stress concrete is that you will be able to counteract the stresses even with the along the length of the cross section, if you are going to change the geometry of the duct. Okay, so that is a thing. For same section, if you are asking, then again it depends upon same grade of concrete and steel. If each and every parameter you are going to keep same, then you can say that more effective session would be pre-tension pre-stress concrete, because there the losses are less. Because in pre-tension in post-tension pre-stress concrete, because there the losses are less. Okay, in post-tension pre-stress concrete the net losses are less for a same section. So I would be saying that post-tension would be selected. Are you getting the point or not, dear Ankit? Okay, so now what are the assumptions involved in the analysis? So as I told you, it is the BTech assumption. I think in RCC only I have written this assumption 3 to 4 times. Plane section before bending will remain plane after bending. Means strain diagram is linear. I think once I have written in column, one time in LSM, one time in WSM. Ultimate load we didn't cover, otherwise we could have written the same even in ultimate load method. Okay, so within the limit of deformation, Hooke's law is applicable. Within the limit of deformation, the Hooke's law is applicable. Okay, stress is directly proportional to strain. So pre-stress concrete is just like your working stress method. In working stress method also the stress and strain were linear. Here also the stress and strain are linear. In working stress also we took the help of modular ratio, and in pre-stressed concrete as well, whenever the area of steel is more and it is deviated from the centroid, we also sometimes take the help of modular ratio. So if we have to resemble it with one, either with LSM or WSM, तो मैं बोलूँगा कि WSM के साथ इसकी resemblance ज़्यादा है. Okay. The stress in the reinforcement does not change along the length of the reinforcement. Otherwise, it is not the practical thing. In practicality, as you are going interior to the section or exterior to the section, the stresses are going to change. Concrete steel is not going to have same stress as it is going to have at the end. It is changing. It is decreasing. as we are going interior. Okay, but the assumption says we can assume it same. Okay, it's just like listen to me. Suppose this is a concrete section. Listen to me. Suppose this is a concrete section, and I have applied a wire here. Suppose if I am pulling it wire, if I am pulling this wire, and this is P, let's say 1000 or 100 kilonewton. So this 100 will not remain 100 here and here. Okay, because due to the frictional loss and many other kinds of losses, this value would be decreasing. If I am going to pull it from both the end, then this loss would be maximum at the center. If I am going to pull it only from one end, then this loss is going to be maximum at the other end. Okay, the earlier case is known as jacking from both the end. This case is known as jacking from single end. Okay, so but assumption says that if it is 100 applied here, then we have to consider it same at each and every position. And one more thing, whenever you are going to apply a load here, it is going to deform. If it is going to deform, then what is happen? This wire would be stretched. Due to the stretching of this wire, again there is some gain of strain, and due to that gain of strain, gain of stress may also be there. Anyway, we are also going to ignore that. So same thing they have written, that the variation of stress in steel reinforcement due to external loading is ignored. Okay, so nowadays precast buildings are being constructed in some cities. If these pre-stressed concrete has to do something, if this pre-stressed concrete has to do something in such kind of construction. Yes, Ram Singh. Generally they use beams of pre-stressed concrete. Precast buildings are just like your steel sections. You already had rod section in your factory, and on site you are only doing assembling. So this precast buildings are also taking the help of pre-stressed concrete. The designer will ask that I need a beam of this much capacity of this size. Okay, so they are simply preparing those individual segments at some other location based on your request, based on your dimensions and all, and you are simply assembling them or keeping them at your site. Okay, this is just to increase the rate of construction or reduce the pollutions involved or reducing the disturbance to the surrounding. Okay, is it clear? So now the analysis method. So total there are three types of analysis. One is stress concept, another is load balancing concept, and third one is P-line C-line method. So I will tell you, I will suggest you to go for all these three methods. But anyway, if you have to select any one that you want to learn analysis only by a single method, then I will recommend you to go for load balancing concept. Okay, stress concept you all know. I taught you in column, in SOM as well I have taught you how to deal with the stress concept, but instead of load, here the moment would be generated due to the pre-stressing force. Okay, and also try to learn the load balancing concept here, and P-line C-line method also we will be seeing. Okay, but yes, one thing is there, today I cannot take numericals. It is only revision session, so only theory portions would be covered. Once again I am reminding you, if you need numericals as well on this pre-stressed concrete or on RCC, then you can watch my comprehensive course. And if you are interested only in watching numericals of pre-stressed concrete, then you can watch my course on pre-stressed concrete available on same channel, Unacademy CECH. Or if you have Unacademy app installed in your mobile or in your device, then you can also check out my course. Free course is there on pre-stressed concrete. I think 5 or 6 lectures I have taken on pre-stressed concrete. Okay, one is on introduction, second is on stress, third math is on load balancing, and fourth one is on P-line C-line, fifth one is on the numerical portion only, and sixth one was on you can say losses. Okay, चलिए, स्ट्रेस कंसेप्ट कुछ भी नहीं है, बहुत सिंपल है, सबको आता है. ओके, मैंने सब कुछ बना के लेके आया हूं आप लोगों के लिए। मान लीजिए आपका कंक्रीट का सेक्शन है, मान लीजिए आपका कंक्रीट का सेक्शन है डियर। ओके, suppose this is your concrete section and this is your beam, and here you have applied load P. Okay, so now what is happening here? So total stress which is acting on this cross section, this is the cross section, this is the cross section. Let's suppose it is having B and D, or area is A, and you can also calculate the I here. I is BD cube by 12, it is BD cube by 12. Okay, so BD cube by 12. So this is P by A. P by A, actually it is just like your column. See, whenever you are going to pull your steel, by the same time concrete is also going to pushed. So if you are considering section as a concrete, then there would be compression in the downside. If there is a compression in the downside, so this compression I am transferring at center, this compression I am transferring at center. So this P will be acting here now, this P will be acting here now. In addition to this P, due to this eccentricity E, one moment will also be coming here, which is known as P into E. So now the stresses which would be generated here would be the combined action of direct stress, direct force, as well as bending moment. So two stress functions are involved here. One is the normal force function, another is bending force function or bending moment function. So due to the normal force which is transferred at the center, the compressive stresses are P by A, and due to the bending stress, due to the bending moment of P into E, the stress developed would be indirect, and it can be computed with the help of bending equation, which is M upon I into Y. So what is M? It is P into E. What is I? It is BD cube by 12. What is Y? It will depend upon the distance of neutral axis, and don't remember it is going to vary linearly. And this both diagrams are only due to the pre-stressing. P is pre-stressing force. So eccentricity of P is also due to pre-stressing force. So this diagram A and diagram B are solely due to pre-stressing. It may happen that eccentricity may be 0 in some times, and the wires that we have provided at the center, at that time this component will be absent. At that time this component will be absent, because due to 0 eccentricity no moment will be produced. Okay, sometimes what can happen, you may have even different shape. Like here we have horizontal, so it may happen that we may have like this, we may have the shape like this. So here eccentricity is going to change at each and every cross section. So we have to be very careful whether we want to analyze this portion or this portion or this portion. So as I am changing the cross section, the value of eccentricity also change. So there you can see we have to find stresses at the different cross section, and whenever we are changing the cross section, we also need to check the change in eccentricity. So the actual eccentricity available at that cross section is going to give you the actual bending stresses, and those bending stresses are to be clubbed with the direct stresses. So as a result, you can combine these two. Are you getting the point or not? So diagram A and diagram B, they both are due to the pre-stressing. Diagram A and diagram B, they both are due to the pre-stressing. Now after we have checked for pre-stressing, it's time to calculate external load. So external load is how much? External load, suppose it is here, let's say W. Let's say this W is also including the dead load of this structure. So total load here is W now. If total load is W, then what is happening here? Then it is going to produce a bending moment M. Once again I am repeating, if it is a case of constant eccentricity, even then whenever you are going to change the section, this bending moment is going to change. So be specific that for which particular section you need analysis. If you need analysis for center, then bending moment here may be WL square by 8. If you need your analysis at the quarter, then bending moment may be 3WL square by 32, 75% of WL square by 8. If you need analysis at the corner, then bending moment external may be 0. Okay, so double check twice that which section you need to analyze. Which section you need to analyze. Are you getting the point or not? Tell me all of you. Okay, so you can see that this is the cross section and we are smartly converting this to this. It is P plus P into E. This is P plus P into E. Okay, so now the compressive stresses would be more at the bottom in this particular case, and at the top it is the resultant of compression and tension. Okay, so this is M upon I into Y. So for this shown loading, it is compressive. So below the neutral axis compression will come due to pre-stressing, because below the neutral axis compression is there and above of the neutral axis tension is there. But when you are considering the external load, due to that sagging moment will try to implement, and this sagging is going to create compression above of the neutral axis and tension below of neutral axis. Okay, so accordingly this is compression and tension, compression here and tension here. So now when you have to obtain the net stresses due to all pre-stressing as well as dead load, live load, etc. So you can check out the final stresses at top and bottom fiber by this expression: P by A minus plus P upon I into Y, and due to bending moment it is plus minus M upon I into Y. This minus plus or plus minus are with respect to this diagram, because tension is there due to pre-stressing force above of the neutral axis and compression is there due to the external load above the neutral axis. So compression is plus here and tension is minus here. So below of the neutral axis compression due to pre-stressing and tension due to external load. So these are the final stresses at top and bottom fiber. Okay, so this is the case. Now the second concept is load balancing concept. So from name itself it is clear that here we are going to balance load. Here we are going to balance load. Actually the changed eccentricity of your wire is going to be compensated with the help of equal, or you can say balanced load. So this eccentricity, how you are going to rectify? First of all, stretch your wire and make it horizontal. Okay, जैसे अगेन मैं कहूँगा कि रस्सी होती है कपड़े सुखाने वाली, उसको आप एकदम खींच दीजिए. Try to make it horizontal. So in order to make it horizontal, you can feel like some upthrust is acting. That's why it is horizontal. So what is the exact amount of that upthrust? You need to calculate that. So only two cases we have to study. One is of triangular loading, triangular profile, and another is of parabolic profile. So had it been a case of triangular profile, then if we are going to make it perfectly horizontal, then you may experience that yes, some upward upthrust point load is acting at the center. Okay, so you can see like this. If you are going to stretch your wire like this, if you are going to stretch your wire like this, then it is going to expand and you are also going to get 2p. Okay, in fact 2p sin theta. What is 2p sin theta? If this angle is theta, so from mechanics, if here it is p and here if it is p and this angle is theta, then this force is p sin theta, and from here as well this force is p sin theta. So total it is p plus p sin theta plus p sin theta, it is 2p sin theta. So if you are going to make this wire straight, then an equivalent load of 2p sin theta is going to come. It is going to come. So now my dear friend, what you have to do, you have to repeat the same procedure as we did in stress method. But the thing is, whenever you are calculating the external load now, earlier you were calculating the bending moment only due to external load, but now also account this 2p sin theta in your external bending moment, and rest of the procedure is same. So you may ask, sir, what is the benefit of this method? The benefit is, if it is a case of a triangular profile and you have to analyze it with the stress method, then it is eccentricity here is changing at cross section by cross section. But whenever you are making this profile straight, so you are getting rid of eccentricity. Only this 2p sin theta, which is a variable which is a load, it is going to accommodate with the external load, and you will be able to calculate the net bending moment, and rest of the procedure is same. But Suppose if it is parabolic variation, suppose if it is a parabolic variation instead of triangular, then in order to compensate, in order to make this parabola horizontal, you need to provide here an upthrust in the form of UDL. So it is very easy. Like for point load, we have triangular bending moment. So this is the shape of the triangular bending moment. So if you are going to remove this bending moment, you need to apply an equivalent load. Like for UDL, we do have parabolic bending moment diagram. So if parabolic profile is to be removed, then you have to apply some UDL. Okay, so what should be the intensity of this UDL? It is also very easy to calculate. Suppose if this is a UDL, then what is the maximum bending moment which it would be producing? It would be WL square by 8. Suppose if it is it is going to compensate your P into H. So what is your P into E? This is going to be the you can say bending moment due to the external pre-stressing force. So for limiting condition, both has to be same. So W is coming out to be 8 PE upon L square. So this is the way to make out the intensity of UDL from this load balancing concept if it is a case of parabolic profile. So in triangular profile, it is simply 2p sin theta, where theta is the angle, this angle, okay, which is constant. But if this angle is not constant and profile is parabolic, then this parabolic this parabolic profile can be considered straight, and you have to apply some load here, UDL here, and the intensity of that UDL is 8p upon L square. Okay, so this is the second approach. Now dear, the third approach is P line C line method. It is also a very interesting method, and generally we use this method whenever we have to draw the locus, of a point. So in P line C line method, P line is known as the cable line and C line is known as the pressure line. Okay, so P line is basically the location of pre-stressing force at different cross section. C line is the locus of resultant thrust force at a stress diagram at different cross section. So the thing is, at every section P and C forces are same, then only you can maintain the equilibrium. And if you are going to do the sum of stresses at top and bottom, however, it is going to constant. These 2 points are also applicable for earlier method. The sum of top and bottom stresses are constant. Okay, the sum of top and bottom stresses are constant even in earlier method as well. So what is happening here in P line C line method that I can simply tell you. Suppose if this is your cross section, listen to me very carefully, and let's suppose this is your centroidal axis, and suppose this is your steel, this is your steel. Okay, so first of all, try to find suppose if P and C are transferring here, so in this cross section, where is the location of force which is going to balance it, so that you can calculate on the basis of bending moment. So if that moment you are going to divide it by C force or P force, you would be getting an X. So let's say your X is here. Okay, now in earlier methods you are using this eccentricity, but now in this method you have to use the eccentricity of this compressive thrust. So let's suppose this is a compressive thrust C and it is having the eccentricity of E dash. Now what is the effective stress? It is C upon area, which is equal to P upon area. It is plus minus C E dash upon I into Y. No need to calculate the external bending moment, because already you have calculated X as per the external bending moment. This M is the external bending moment and it is due to your given load. It is due to your given load, dead load and all. So accordingly you have changed the direction of lever arm and you have recalculated the value of your eccentricity. So with respect to this zone, now you are working in compression zone. So if you are going to calculate value of E dash at different cross section, you can also locate the locus of points through which compressive forces are going to pass. So this is your third approach. Okay. Now my dear friend, losses. For this I do not have PPT right now, but I can explain you the various types of losses in pre-stress concrete. Okay, but yes, one advice here, that try to attempt problem, at least two problem by all these three method. And what I will do, what I will suggest you guys, try to take the same numerical, and that same numerical try to accomplish by all these three method, that is P line C line method. Okay, that is by load balancing method as well as by stress method. So use the same method, use same question in by all these three methods. So automatically you will be able to differentiate between the exact mechanism of these processes. Okay, so now P line C line method, oh sorry, losses in pre-stress. So what all are the various losses in pre-stress? So if I am writing here, so first one, this losses is due to friction. Second, these are losses due to anchorage slip, deformation, etc. Third one is losses due to elastic shortening of concrete. Fourth one, losses due to creep of concrete. Fifth one, creep of steel. Sixth one, shrinkage of concrete. Steel नहीं shrink होगा ना, shrinkage is the surface property. So friction, anchorage, elastic shortening, creep of steel, shrinkage. So these six are the major causes of the losses in pre-stress concrete. Okay, these six are the main causes of the losses of pre-stress concrete. So why I have made here green color and why this blue with blue color? Because this green color losses happens only in pre-tensioned, pre-stressed concrete. Also in post-tensioned, pre-stressed concrete. It is pre-tension as well as post-tension. But this blue losses only happening in post-tension, pre-stressed concrete. Okay. So if I am talking about the total number of losses, it is more in post-tension pre-stressed concrete than the pre-tension pre-stressed concrete. But if I am talking about the magnitude of losses, so magnitude of losses are more in pre-tension concrete. The losses due to elastic shortening of concrete and creep, they are higher in magnitude than in comparison to post-tension pre-stressed concrete. Okay, so once again I am repeating, the number of losses are more in post-tension pre-stressed concrete, but the magnitude of losses is more in pre-tensioned pre-stressed concrete. Okay, now losses due to friction is the loss which is occurring during the tensioning process. Okay, and this friction loss is basically due to two factors. So friction loss is basically due to two factors. First is length and second is curvature. So there is a combined formula to calculate losses due to friction, which is initial pre-stressing force into kx plus mu alpha. Okay, mu is known as the coefficient of friction, alpha is the change in slope, So friction and slip doesn't occur in pre-tension. Yes, friction and anchorage slip, they do not occur in pre-tension. Yes, this is what I mean. Yes, Bhavik, but friction and anchorage slip in pre-tension is elastic shortening, but friction and anchorage slip is not there in pre-tension. Okay, so K is your wobble correction coefficient. Wobble correction coefficient. And X is here distance where loss is being found out. And P naught is obviously the initial force, initial pre-stressed force. Okay, it is the initial pre-stressed force. Okay, chaliye. Next is I'm not going into the detail of this terminology. What is alpha, on what factor alpha is going to change, but this alpha is also going to change and X is also going to change depending upon the jacking condition. Sometimes we are pulling our wire from one side and sometimes we are pulling it from both sides. If the pulling is done from both sides, then maximum loss is happening at the center, so X maximum value is L by 2. If pulling is done from both the side, then change is there with respect to center, so change in angle with respect to one center. But if pulling is done from one end, then the maximum value of X is L, because it can happen maximum at a distance L. And if change is pulling is only from one side, then in that case your angle change can be with respect to this tangent. It can be 2 alpha and all. Okay, so like that variations can be there. This thing is never asked in past. Okay, wobble correction factor also you can see what is its value when different, when base is different, medium is different. On all these parameters this value depends. Yes, but it is important for your engineering services. Okay, next type of loss is quite simple, which is simply the anchorage slip. So anchorage slip loss is quite common and you can even identify it from the basics. Okay, suppose if anchorage slip is given to you, it is delta, losses due to anchorage slip, है ना. प्री स्ट्रेसिंग प्री टेंशन में तो एंकरेज ही नहीं होता, तो स्लिप कैसे होगा. सो इफ इट इज delta is loss due to anchorage, then strain is delta L by L into yes. So this is the stress loss, and you can multiply this stress with the area and all in order to get the loss for pre-stress loss. Okay, so directly question came in gate that anchorage slip is this much, initial pre-stressing force is I think 1200 mm square. So what is the percentage loss due to the anchorage slip? So all you need to do that deformation divided by L multiplied by ES, which is 2 into 10 to the power 5, then you can find the percentage. Okay, now the next kind of loss, next type of loss is loss due to your elastic shortening of concrete. When will we get out term 1 result? What is term 1 result here? So here the consequences are different in different mechanism, in different type of steel, or sorry, not steel, type of pre-stressing. If it is a case of pre-tension, if it is a case of pre-tension, it is wrong channel, dear Karthik. It is a wrong channel, dear. It is for engineers, that too civil engineers. Pre-tensioned members. So loss is m times of Fc. Loss is m times of Fc, where Fc is the stress at the level of steel. But if we are talking in terms of post tension, then it can be even 0, or it can be even not equal to 0. It is 0 because when all wires are stretched simultaneously, and it is not equal to 0 when wires are stretched one after another. Okay, so that are the cases. Okay, so now this is the elastic shortening of concrete. Next is loss due to creep of concrete. So it is, this loss is equal to how much? Phi times of mfc, where phi is creep coefficient. Phi is creep coefficient. Creep coefficient I also explained you in lecture number 1 marathon. It is creep strain upon elastic strain. Okay, and fourth one is loss due to creep of steel, and this value is generally 1 to 5% of initial pre-stressed okay clear है कि नहीं है? And then loss of stress due to shrinkage कितना होगा? It is 3 into 10 की power minus 4 ES in case of pre-tension, and it is 2 into 10 की power minus 4 into ES upon log 10 T plus 2, where T is in days in post tension. Okay, in pre-tension and post tension. आ रही बात समझ में? So total these 6 category of losses are there. Okay, shrinkage of concrete, creep of steel, okay, creep of concrete. So I think this is loss due to friction, okay, loss due to anchorage, loss due to elastic shortening. This is fourth one, na? This is fifth one. And this is sixth one. So, and remember one thing, that number of losses although are more in post-tension pre-stress concrete, but the magnitude of losses are less in post-tension pre-stress concrete. Okay, so this can be the key. Okay, so all these are the various types of losses. Is it clear to you? So GATE have asked only question on this so far. Okay, but remaining are useful for your ESC prelims as well as ESC mains. isn't it? Okay. So dear, we will be keeping only up to here. So I hope this marathon, this session will also be useful for you in revising your pre-stress concrete fundas. So I have covered almost all the topics excluding numerical I agree कि मैंने नहीं cover करा है. So just a quick recap जल्दी से. So pre-stress concrete का हमने introduction देखा, then why pre-stress concrete and what is the benefit of pre-stress concrete, why do we need high strength steel and why do we need high strength concrete. Okay, then two types of pre-stressing we have seen, pre and post, their pros and cons, and minimum grade requirement in pre as well as in post. The criteria in pre is bond, whereas in post in bearing. What are the advantages of pre-stressing concrete? Assumptions in the analysis. So three methods of assumption analysis: stress method, then load balancing method, then P line C line method. Okay, then finally friction. Total 6 cases, out of which the first 2 is only applicable for post tension, whereas all 6 are applicable for pre tension. Okay, so we will be keeping up to only here. So let's finish it here. Okay, so try to watch it along with the RCC marathon. You can consider it third marathon of RCC, isn't it? So live mentoring is there, dear, with all the new iconic subscription. You can go for that. Special classes are going to interactive in nature. Polls are there. You guys can raise a hand here. You are not going to miss a class. Lecture notes you can get available and you can access it from any time. You guys can also check out the brand new updates on Unacademy Ask a Doubt, which is the faster and better way to solve doubt. This is our official Telegram channel here. Join this for the YouTube notes as well as notification. And we do have lot many free content available on special classes as well as on Unacademy official YouTube channel. But still I recommend our learners to go for our Plus plan and Iconic plan. Because Plus में आपको मिलते हैं daily live classes, weekly test, structured course, crash courses, RIV as well as unlimited access to the content. And if we are talking about the Iconic one, जहाँ पे आपको पर्सनल कोर्स दिया जाता है, स्टडी प्लानिंग होती है, स्टडी बूस्टर सेशन, personalized test analysis, specialized notes and practice sets along with the dedicated doubt clearing educator. So Unacademy subscription prices are available from 3 months to 2 year and plus के होते हैं 6 months to 2 year. और आज अगर आप प्लान करते हैं अपना सब्सक्रिप्शन 12 बजे से पहले, अभी भी 20 मिनट्स हैं, तो you would be getting 20% off instead of 10%. So guys, thanks a lot. Take care. Stay safe. Bye bye.